we looked at just some inequalities, what they mean if you put and or in between them and graphing them last class. So now what we're going to do is solve some equations or equations involving inequalities. So you do it the same way, but do you remember what the difference is when you solve an equation that has an inequality instead of an equal sign? Do you remember what the difference is? There's one rule that's different than just rearranging it. Does anyone remember what that is? It's when you divide both sides by a negative. Anyone remember that rule? If you divide both sides by a negative, you have to switch the sign. I don't really like that rule, so what I usually do for it is just put the x on the side that will always be positive. The x always has a positive number in front of it. Then you'll never divide by negative and have to remember to switch the sign. Right? So with inequalities, that's what I usually do. You could do that with equalities as well. Always move the x's to the side so that they're positive. And that way you don't have to remember any special rule. So with this particular question, there's no special rule because we just treat the greater than sign as if it's an equal sign, move the 1 over. Divide both sides by 2, and x is greater than 2. So usually with these questions I'll say state your answer and graph it on a number line. So you would center at 2. You can put one number before and one number after. We're greater than 2, so it empty circle at 2 and then just shade it in greater than 2. Now you can always, and just, there's our answer. Okay, so that's what I would be looking for. Okay, so answer and a number line. You can always check your answer, and a good way to check to make sure that your sign is going the right direction, you weren't supposed to switch it or anything, is to pick a number that's bigger than 2, say 3, plug 3 into the original equation. So we're going to check x is 3. You could check any number bigger, 10, 100, doesn't matter. Plug it in, 2 times 3 plus 1. That's 6 plus 1 is 7. Is 7 bigger than 5? Yes. So we've got the right side of the 2. When you plug the 2 in itself, what will we end up getting? 5, exactly, right? So it's not going to say if we have the right side. It's going to say you've got the right number. The number is worked out to be 5, but we actually don't even want it. We want the ones bigger. So always check one that's in the range that you want rather than the exact number where you're starting. Okay, number 2. You don't need to check these ones, but you don't need to check these ones. But when we get to quadratics, so when we have x squared in this equation, we have to check them. So if you start checking them now, you'll be in the habit of doing that, and then it won't be something different. Okay, and actually in calculus where you use things like this, you always end up checking them as well because you're actually looking for something else beyond just this number line. So it's a good habit to do, but not necessary. But you can always check your answer, especially on a test. So let's say less than or equal to 1. Okay, so negative 2x plus 3 is less than or equal to 1. And this is what I'm talking about with the negative. If we move the 3 over, and you see here we have to divide by a negative 2. The rule is when we divide by a negative 2, we have to switch the sign. So this would then be x is greater than or equal to 1. Negative 2 over negative 2 is 1. If you forgot and left the sign the other way and then you check it, you'll have the wrong side. It won't work. Okay, so I'll show you that. So if we put this on a number line, 1 is colored in because of the equal sign, and we want greater. Okay, so that's the correct answer. So let's suppose that we did it incorrectly and didn't switch the sign. Okay? So what would we have? So what we would end up having is x is less than or equal to 1, because we would have that sign still the same way if we didn't switch it around. Okay, and then that goes the other way on the number line. We would go this way. So this is where checking is useful, because here you'd say, okay, well I got this. If I check my answer, so I'm going to check 0 because 0 is less than 1. Plug it into the original equation. So we're plugging 0 in, so minus 2 times 0 plus 3, 0 plus 3, is 3 less than 1? No. Why is it wrong? Well, we went the wrong way. So if you then tried 2, 2 would end up working. Okay, the other side, the correct side would actually work, the wrong side won't work. So, and I already said, I don't actually ever do this switching sign thing. What I do instead is, what did I say? Instead of worrying about remembering to switch the sign, if you always move the x so that the x doesn't have a negative in front of it. So if we did this question again, negative 2x plus 3 is less than or equal to 1, okay? So backing up and saying, I know I'm going to forget to switch that sign every single time because it's not something I'm going to remember. So what you need to do then is say, when you're solving any equation, whether it has an inequality or an equality, put the x's on the side so they're positive. So we're going to move that over, and we'll leave the numbers on this side. So 3 minus 1, and if we move that 2x over, it becomes a positive 2x. Does that make sense? So just switch the sides so that the x is positive. Now we'll have 2 is less than or equal to 2x. Divide both sides by 2. 1. Now this is sort of hard to read. That's the problem with doing it this way, and why people don't just tell you to do that in the beginning, is it's a little harder to read. So look at it and say, okay, the big part of the inequality is towards the x. See, and it's pointing towards a 1. Think of that as an arrow. So when I rewrite it with the x first, this is like an arrow pointing at the 1. So I need to, when I want to read what it actually says, you say x is greater than 1. You don't read an inequality with the number first. So do you see we're kind of switching the sign anyway? But it's after you have the answer rather than in the steps. Okay, so x is greater than 1, which is the right answer for that. And if we check 2, it will work. So, and we can put anything. We can put fractions on both sides. We can put anything on each side, same as what we've done so far. Okay, so how would we solve this? We would expand first, multiply that out. 2x plus 6 is less than 4x minus 4. Now, which side do we want to move the x's to? To the right or the left? To the right, so that the x's are positive. So that's the difference with these. So we're going to move that over, and the 4 then will go this way. So we have a 6 that's staying. Move the 4 over. Write the same sign. 4x is staying. Move the 2. So we've rearranged it so that the x is positive. Divide both sides by 2. And just switch it around so that you can read it. X is greater than 5. And check your answer if you're worried that you've got the wrong thing. And to check your answer, always plug it into the original, right? Not anywhere after you've changed it. Like, for example, don't plug it into this step, because what if you multiplied wrong in that first step, and then you're checking the wrong equation? So you always go back and check it right in the very original to make sure it works. And with these, you would check the 6, not the 5, because the 5 will just make both sides equal. We want to make sure that you're actually shading the right direction. So if we were to check, we would plug in, like x is 6, into the original equation. Six plus 3, and 6 minus 1. 18 is less than 20. True. So we've got the right side. Okay. These are much more complicated, and we don't really do a lot of these, so I'll do one example and show you. It's a little more complicated because what values cannot work in this original equation? 0 and minus 1. And remember, we're going to shade a whole part of a line. We're going to shade, so we might go through those numbers, in which case we now have to take them out. So it's a little bit more complicated. The x can't be 0 and x can't be negative 1 will probably now matter, is what I'm saying. Where before it didn't really apply. We sort of looked at it, but we didn't do much with it. So here, if we cross multiply, 2 onto x plus 1 is less than 3x. Multiply this out, 2x plus 2. We're going to move the x's to the right, so they're positive. And we have 2 is less than x. Switch that around, so it says x is greater than 2. Of course, the conditions didn't matter in this case. Why not? Right, 0 and negative 1 are down here, and they're okay. We didn't go through them. So let's switch the sign and see what happens. So there's our answer, and it's okay, because those two ones that down here that would make it not work aren't even in it. So here's the same question, but I put a different sign in it. Right, so I just switched the sign, I've switched the direction, I've made it equals instead. So what is going to happen when we solve it? Same thing, except the sign's going to look different. So here x is less than or equal to 2. Here we had x is greater than 2. Now be careful, because the conditions that we had, that x can't be 0 and x can't be negative 1, because you can't plug those into the original, or you'd have divided by 0. Here's negative 1 and here's 0. And we want to go in that direction, less than. So there will actually be more holes in the graph. So any value that you can't have would have a hole, and then everything else is shaded. So we can have all these numbers in between. That's not just 1, it's 1.1, it's 1.9, it's all the numbers in between 0 and negative 1, which are all those decimals, and then beyond. So we would say x is less than 2, x can't be 0, x can't be negative 1. Okay, now I said that's a little bit complicated. It's just like an extra step, and we're not really going to do a bunch of those, but I just want to show it to you so that you know it exists. Oh yeah, thank you. So the 2 is shaded because there's an equals to, right? See it? Right, so there's 2 holes in the graph, not 3. Okay, so now we're going to mix the 2 together. So last class we did absolute values by themselves and you got 2 answers. Then, so far today we did inequalities where you just rearrange it, but watching the sign in front of the X that it's positive. You can also check your answer in case you made a mistake. Now if we put them together, we talked about this last class, what does this mean? So this is the distance is bigger than 3. So on a number line, this is the distance from 0. So the numbers that are bigger than 3 can be out here or down here. Because if we put a -4 in there, and then it's +4 is also bigger than 3, right? So when you see an absolute value and an inequality, and then you need to solve the equation, you actually have to rewrite it first, so there's a first step before you solve it. So the first step for this is to rewrite it as x is less than -3 or x is greater than or equal to 3. Why or? You can't be here and here at the same time, so it has to be here or here. It can be in one of those places, but not both at the same time. And then the other one is when we say x is less than or equal to a number. So where are they on a number line? So it's in between, and how do we rewrite that? We write the smaller number first, and the bigger number after the x, and we say that x is between -3 and 3. Okay, so those are the 2 options. So you have to remember which they are, but if you always go back to thinking about what it means, the distance is bigger than 3, that means it has to be farther away. The distance is less than 3 means it has to be in between, right, closer to 0. If you remember those 2, you won't mess them up. So, let's do a question. So the example would look something like this. So it has more than just an x in it. So what you do is you say, okay, well this is greater than 6. So here's -6 and here's 6. Is it in between the 2 or is it on the outsides? Outsides, because it's greater. So it's going to go this way and this way. So, but it's not just x now. What is it? X plus 1. So x plus 1 has to be less than or equal to -6. That's down here. Or x plus 1 has to be greater than or equal to 6. And now we have 2 problems to solve. Just like when we did regular absolute values, there was 2 answers. There was always 2 problems to solve. It's equal to 6 or -6. And now we're either bigger or smaller than 6 and -6. So there's 2 problems to solve, and then what we did at the end of last class was you have to look at them on a number line to decide what the answer is. That's what you have to do at the end. So we solve each of these individually. So this is step 1, you rewrite them. And then step 2 is solve each of them. So this will be x is less than or equal to -6 minus 1. And that's it, that's solved. Solve the other. So here's our 2. Step 3 is to look at them on a number line, just a rough sketch to see where it goes. So greater than 5 is this way, and here it was an or, So both of those are okay, and that would be your answer. So our answer, I'm writing as a separate, so solution is that x is less than or equal to negative 7 or greater than or equal to 5. There's an equal, so color them in. And that would be what you're looking for. You have to have the word or and in between. With these ones, it's going to always be or, because that's how we started the question, with an or. You're not going to ever change that to an and. Okay, so with these, we started with going on the outsides, but when we actually worked it out, it moved by 1. So instead of -6, it moved down by 1, and instead of 6, it moved to 5. If the question, the next question, the less than is going to be an and. So greater than is or on the two outsides. Less than, when you're going inside, is and. So that's what I'll write down next. So example 2. Okay, so less than 5. So we're going to rewrite that first. So step 1. Now this was less than, so you're thinking about your -5 and your 5, but we're saying less than, so it's going this way, in between. So our two equations that we write, you can start with it saying in between. But then we actually have to split them up to solve it, because you can't solve a question that has two inequalities in it at once. So the way we split it up is we say that -5, like that, and 3x minus 1 is less than 5. So you're going to take the middle, and you write that as one equation, that whole thing. And then what did I do for the other one? You take the middle with that equation. And it's and, because we want it to be both bigger than -5 and less than 5 at the same time. So we want to see what those new numbers will be. Okay? So now you've got two equations to solve. So greater than, when it starts, is on the outside. So if you draw that little sketch, you'll say, okay, it's or, because they're not overlapped. Less than, when you write it out and then you split it up, and that's an and, because we're both at the same time. And then you solve these. So step 2, the 3x is already positive, so I'm going to leave it where it is, and I'll move the 1. Okay. And then the other one, the 3 is already positive, so I'll leave it where it is. Now, same step 3, draw them on a number line, but we're looking at and now, so we're looking at the overlap where they go together. So -4/3, you don't even need to know what that is, you just need to know that it's smaller than that number. Let's put it to the left. This says what? X is greater than -4/3. So that way. This says, oh, not equal, so an empty circle. And less than, so it's still in between. And then you can write your solution. So -4/3, empty circle, in between, and our answer, when it's in between, has to look like that. Now, will that always happen when it starts in between that it's going to end in between? When it starts going outside, it ends that way? I don't know. Let's do a few more. Did everyone get that one? Okay, so here's the next one. Step 1, decide how you're going to rewrite it, either in between 1 and -1 or on the outsides. Which one is this? So less than would mean in between. We want the smaller numbers. So we're going to say in between. That would be your first step. So my first step is always this, just to remind myself, okay, am I going in between those or on the outside? So how do I know that? Well, less than 1 has to be the numbers smaller than 1. Then you split this up. As 2 equations. And what do we put in between? And or? And, because we are both bigger than -1 and less than +1. So that has to be an and. Then solve each. So the x is negative this time. So let's move it to the other side. So this will be x. The 3's already on this side, move the 1 over. So x is less than 4. This one. Whoops. I get x is greater than 2. So 4 and 2, greater than 2 goes that way, less than 4 goes that way, so is it still in between? Yeah. We'll do another one. So it's still in between, so what do we say our answer is? Make sure you put the numbers in the right order. We started with the -1. This one ended up being the bigger one on this side. I don't know if any of you noticed it sort of switched, but that's because of the negative in front of the x. Okay, but you don't need to worry about it if you didn't notice, but small number, this is x is bigger than or equal. So color them in, and it's in between, and then write your new solution. What about these? Here's 4 questions. All the same question, the only difference is the way the signs go and whether they have an equals or no equals. You agree? So when we solve for the x value, we will get the same x value each time. Yeah? So this one right here. What's everyone think? And I'm asking for a thought before solving anything. So absolute value is a distance, and I'm saying it's bigger than 0. Is the distance always bigger than 0? Yeah, the answers to an absolute value always have to be positive, so they are always positive. What about equal 0? There's a number I can plug in to make it equal 0. Well, it'll be -4/3, but yes. This is just always true. The absolute value of something It's greater than or equal to 0. True. Yes, it is. Always. X is an element of real numbers. Now, if we go to solve it, we can't put between 0 and 0 or outside of 0 and 0. So how would we solve this? You can't say it's on the outside. 0 is just one number. So we just solve it. 3x plus 4 equals 0 gives me what? Minus 4 over 3. So minus 4 over 3 is the number. If I plug it in, I get 0 as the answer. So here's minus 4 over 3 on a number line. Tell me any number bigger than that. 5, 10, 0, 100, 1. Any number bigger. Say 1. That's a negative number, so 1 is a number bigger. What about a number smaller? Negative 2 smaller, negative 10 if you want to really make sure you're far away from it. Okay, is that a number bigger and a number smaller? You can always test and see which side works. So if we plug in 1, for example, into our original, always go back to the original, 3 times 1 plus 4, we get 3 plus 4, absolute value of 3 plus 4 is 7. Is 7 bigger than 0? Yes. So this side works. What about negative 10? 3 times negative 10 plus 4. 3 times negative 10, negative 30 plus 4, negative 26, which is 26. It's always going to be positive. Doesn't matter what's in there because we're doing the absolute value. So 26 bigger than 0? Yes. That side works. Does the 4 over 3 work? Yes, because we want it to be equal 0 as well. So this side works, and the number in between works. So all real numbers. So the solution for this first one is that x is an element of real numbers. That's the solution. What about this one? No matter what number I plug in, I'm going to get a positive answer. I plug in negative 10, I get 26. Is 26 less than 0? Is 26 less than 0? No. If I plug in a 1, a number bigger, I get 7. Is 7 less than 0? No. So for this, even though the minus 4 over 3 is still where it equals 0, this side won't work and this side won't work. Does the number itself work? Yes, because there's an equal sign. So what's the solution to this one? Yeah, x is equal to minus 4 over 3. That's the only solution. That's the only number that will work, and that's the one that makes it 0. You can't get an absolute value to be negative, so there's no more numbers that work. Just that one. Now what if I take the equals out? Start with this last one. It can't never be negative, and now we don't want it to equal 0 either. So what would the solution to this last one be? No solution. Now this one, everything worked, but we don't want it to equal 0. So how would we say our solution? X cannot equal negative 4 over 3, but it can be anything else. So look at the solution for 3 and 4. This just has one number itself. It does. We didn't put an element of real numbers, which would mean everything else. This one we say, okay, we can't have that number but everything else. So you need that element of real numbers to say that x can be anything else. Here we don't want to put that because we want it just to be one number, not everything else. So we don't want to put it there. And here it's all real numbers but no restrictions. So we don't add anything else to it. So that's a weird case where it's like greater than or less than 0. What if I said like greater than or less than a negative number? Now, can an absolute value be Greater than or less than a negative number? Well, it can't be less than a negative number, but it can be greater. So let's look at a couple more weird questions. So if I said the absolute value of x plus 1 is less than negative 6, what do you think? Just a first guess. No solution. It can't be, because it's always positive no matter what I put in. Can it be less than negative 6? No. Can it even equal negative 6? No. This is just no solution. But you don't want to accidentally set up some equations and solve them. So you have to be careful of that. If I put the equal sign in there, less than or equal to negative 6, does that change anything? Can it equal negative 6? No, because it's always positive, right? So no matter what I plug in, I can't get an absolute value to be negative. So this is still no solution. Why was this one okay? Because it was equal 0. 0 is not negative, it's a number, so it was okay. We could get a 0 inside an absolute value, but we can't make it into a negative. So then what if we had the same question, but I said greater than negative 6? There are some places where it's greater than negative 6. Like here's negative 6, and here's 0, and then here's positive numbers. Do you agree? Nothing in here will work. This is not nothing, right? Nothing in here will work, but really we could have numbers up here, because greater than negative 6 is all the way. So there are some answers that work, just not, some of them are gone, right? So this question is the same as asking what? How could we rewrite the question and then solve it? Or equal to 0. How come equal? 0 is greater than negative 6, so we want the 0 included. Right? Because we want everything up here, but nothing in here will work because it's absolute value. We can't get a negative. We could get a 0, and we could get bigger. So where is this equal to 0? Negative 1. So here's negative 1. And which numbers are going to work? Negative 1 works. That makes it equal to 0. If you were unsure, it's going to be greater, but if you were unsure of the side, you can always just test a number. What's a number bigger than negative 1? Say 0. If you plug 0 in, does it work? 0 plus 1 is 1. Is 1 bigger than 0? Yes. So our solution here is that x is greater than or equal to negative 1. Nothing at all to do with the 6, really. Right? So there's some weird things that you would have, even if you had seen these in high school, they wouldn't have shown you this stuff, because what they do in school sometimes is ignore things that are weird and just show you the ones that work nice. Right? But what you actually have to do when you see this is not try to remember a set of rules, because that won't help you. You have to remember what an absolute value means and where is it possible. So you always think about, where would this be if the question had just been x is less than negative 6, absolute value like that, without anything funny in it, where would that be on a number line? Well, x is less than 6 is down here, but this can't be, so you'd say there's no solution. You have to think about what it means before you solve it, and that will really help you to make sure you solve the right thing. Okay, but those are sort of the exceptions to the rule. We don't always see that. So they don't have to be absolute values to have to solve two things at the same time. We could have two different equations with an and or an or in between and then have to solve them. So what's the difference When it's an absolute value, it's symmetric. We're using the same, like 6 and -6, where two different equations, the numbers just don't land evenly apart, is all. So if we were to solve these, now I put an or here, I'm going to do the same question after with an and. So if we were to solve this side, the 2x is positive, so let's leave it there. Okay, so there's our first side. Our second. X is less than 1. And there's an or in between. So when we draw them, we want it all. It doesn't matter where it is. We don't need to compare them. We can just draw it all on the same graph because either numbers in here or in here will satisfy the original equation. So where does this look like? We've got negative 9 over 2 is smaller than 1, so they go in that order on the number line. We want bigger than and equal to negative 9 over 2. So we want it to go colored in and this way. Here, less than negative 1. Empty circle and down. Now, it's or. So we're not looking at the overlap. We don't care where they overlap. We want it all colored in. Whatever's colored here is part of the answer. So what's not colored? Careful, the 1 is colored, because it can be in one or the other. And is it not colored for this one? The 9 over 2 and greater? Wouldn't 1 be included in that? Yeah. So 1 is colored in, it's included. Anything else not included? No. So all the numbers bigger, all the numbers smaller. So what's the answer to this? Right, X is an element of real numbers. If it asks for a number line, there's not really much to draw. And I just made it a big line with those numbers on it, but not any circles or anything. Now, what if we change it to and? Same question. So we would solve them the same way. The inequalities are going the same direction. I didn't change anything. So the two answers you would find are the same. It's just what happens when you look at the number line. So I didn't change the question, I just changed whether it was an or an and. We've got the number line up here, so what we're looking for is where they both are. So both are colored in. So where are they both colored in? First look at the numbers. Is negative 9 over 2 colored in for both of those? Yeah. What about 1? Is 1 colored in for both of them? No, because it's not colored in for this one. Now, where are they colored in? It's in between. So this one goes here, and negative 1 goes down. So it's right in here that they're both colored in. So that would be the solution. And we would say that negative 9 is the smaller, negative 9 over 2. And which one has an equal sign? This one, right? But not the other one. And then this would be the answer you're looking for. And you could have any possibility. They could both go in one direction, but wherever their overlaps would be. And we looked at all the possibilities of those last class. And that's what we did at the end of last class, was sort of, if you got these answers, what would you do? Which direction would you go?